All right, everyone, let's go ahead and get started for the afternoon. Congratulations on finishing your first project, making it through your project eval. I think from what we saw, everybody did a great job with this first project. Yeah, and so now we're going to forge ahead and talk about many-to-many relationships. And after that, I'm going to kick off your next project. Before we get into the class today, I want to just do some quick housekeeping. So for your calendar here, I'm looking at the Mod 2 homepage. Instructors are going to be out for this Friday tomorrow. So I put this on your calendar, but you might not have seen it, but we are going to have a backend team planning day. And so we are not going to be with you on Friday. Now, if we're still going to be online, so if any emergencies come up, we'll still be around for that, but we're not planning to be leading any of the sessions tomorrow. So for tomorrow, for the morning, we have two explorations for you. So there's this HTML and CSS exploration, and then a testing best practices exploration that I'm going to have you all work through. I am going to drop some more instructions for these. I don't want you just like reading through these lesson plans. I would like you to get together in some groups or some pairs and just talk through what you learned about. So there is some very key information in here. I mentioned this before, but we're not going to have any like dedicated class time other than this to talk about HTML and CSS. But that doesn't mean that this is not important. So this section on HTML, or this exploration on HTML and CSS, very, very important. And it specifically talks about how this relates to Rails. So it goes into the application layout. It talks about how you can use, how you can actually use your CSS. It talks about the developer tools, which we've talked a little bit about in class, but very, very important that you are know how to use your developer tools. And I would say this last section is probably the least important section, but it'll like start talking about some CSS frameworks. So that's the HTML and CSS exploration. Again, I'll drop some more instructions for you tomorrow morning. And then the testing best practices exploration builds off of the HTML and CSS lesson. So with our feature testing is using Capybara to look at web pages. So it's important to have an understanding of web pages in terms of HTML and CSS in order for us to test them. So this will get into your file structure. It'll get into naming the files and just general organization. It'll get into before each if you haven't seen this yet, which is a good thing to use. It'll talk about some different types of expectations, and then we'll get into CSS selectors. So this is kind of the connection between HTML, CSS, and your testing. So they're all very related. And additionally, it'll talk about testing for sorted elements. So testing for sorting, I think I had a conversation with many of you how for this first project, it's very difficult. You might not necessarily know how to do it, but now we're going to show you how you can do this. And so we're expecting you to be able to test for sorted elements moving forward. So some really key information in both of these explorations. This is what you're going to be doing during the morning tomorrow. And then the afternoon is going to be our gear up on that culture survey that I linked in the in my message earlier this morning, and then also cohort retro. I believe the SLC reps wanted to move some of this stuff around, and that's fine. We might like change the schedule a little bit, but this is what you're going to be doing in the afternoon. If you haven't had a chance to complete the culture survey, make sure you have a chance to do that by the end of today. We really need to have all of that done so that we can kind of compile the results and get those out to the SLC reps. So if you haven't already, please make a note for yourself to finish that before you log off today. So that kind of covers everything you'll be doing for tomorrow while Jameson and I are out. Does anyone have any questions on that? Okay, then. So let's go ahead and talk about many-to-many relationships. So our learning goals here are to describe the relationship between a foreign key on one table and a primary key on another table. We want to diagram our one-to-many relationships. So really trying to ground our understanding in one-to-many relationships. Then we're going to get into many-to-many relationships. So many-to-many relationships utilize one-to-many relationships. So we want to first make sure we're good on one-to-manys before moving on to many-to-manys. We're going to talk about adjoint tables. And then the final piece is how does this look in Rails, which is the tutorial section at the bottom. And we've done this in class already, but we're going to continue to interpret schema.rb. So this is your master copy of what your schema is for your database, knowing how to look at schema and utilize that file. I think most of this stuff is pretty straightforward. This is how you can set up the passing data branch and work on the tutorial section. And I think that's about it. So what I'm going to do next is move you all into some breakout rooms to talk through this warm-up section. So in the exploration instructions, I asked you all to complete this warm-up. So I want you to talk with a couple other people about what you did. Ideally, you can share your diagrams. If you created diagrams, you can share those with your classmates with a screen share, or if you did it in a notebook, just like holding it up to your camera, that should be fine as well. If you didn't do any diagrams, if anyone in your group doesn't have a diagram, go ahead and use the Zoom whiteboard feature and try to make this diagram. Yeah, so I want you to talk through these warm-up questions. I think that's about it. Does anyone have any questions before I let you go? All right, I'm gonna give you all 7 minutes to talk with your group. Hey, Jameson.
Mhm.
All right, welcome back, everybody. I am going to take a random volunteer on my side. And Jahara, you are my random volunteer. Can you talk about what is the relationship between songs and artists? What did you and your group talk about? Oh, I don't have a Jahara, do I? Joe Mecca.
Sure. So we made a comparison to like the project we were just working on. And, looking at how the songs belong to the artist and the artist has many songs. So talking about describing those relationships as well as having the artist key or ID appear as a foreign key in the songs table.
Great job. Yeah, so our foreign key of artist ID. Joe, what is the foreign key reference? So if you have an artist ID foreign key, what does that kind of point to?
It points to the ID of the artist.
Right, correct. It's the ID. How would you describe that ID? What type of column is the ID column?
Sure. So it's the primary key of the artist, and it's a unique number that identifies each record.
You've got it. Yep. So very key information here. If I share here, so understanding primary key is our unique identifier. Foreign key references a primary key. Great job. Can I get a, this is going to be, I'll take a volunteer for this one, a brave volunteer to show what you did for your diagram for this part? And maybe someone with a virtual version so that we could share a screen. Joey, thank you.
All right. Yeah.
So go ahead and talk me through what you've got here, Joey.
So I have the artist table and I have the songs table. The artist table is made up of an ID, which is the primary key, the name, which is a string, and created at and updated at, which are timestamps. And then we have the songs table, which also has a primary key title, length, play count, and then artist ID, which is the foreign key that Joe is describing and is associated with the artist table.
Great job. Looks good. So what Joey is showing us right now, I would say is a good schema diagram. So our schema diagrams show us what the layout of our tables and our columns are in our database, in the same way that our schema.rb file describes those tables and the columns within those tables. So this is a really good way for us to draw out or diagram what our schema is. Yeah, I want to make sure I pause here. Does anybody have any questions before we move on from this diagram? Or any questions coming up so far? Okay, So I'm going to take over the screen share here, and I'm going to do a little bit more drawing. Where did you all go? Where's my Zoom window? I can't find it. Okay, I lost y'all. Let me try that one more time.
If you do Command tilde, it should pivot around the windows.
Yeah, it does not.
Yeah.
It does not want to show me.
Zoom has a weird thing too, where if you like minimized a window, it goes into your dock and gets stuck there until you release it.
That might be what's going on. There it is. I found y'all. Great. Sorry about that. Zoom issues. Anyway, okay. Let's go ahead and draw a little bit more. Can y'all see me drawing? Cool. Thumbs up. All right. So as I mentioned, what Joey showed us was a great schema diagram, which showed us the layout of the tables and the columns. I'm going to take it a little bit further here, and I'm also going to draw out some rows inside of those tables to really emphasize these points here. So I'm going to start with, let me just think through this first. So I'm going to start with songs on the left here. And so just kind of following my schema diagram, our songs are going to have an ID. They're going to have a title, and they're going to have a length, and they're going to have a play count, and they're going to have an artist ID. So let's make this a little bit bigger. And I really want to visualize this as a table. So the term table is not just like, is not a misnomer. It really indicates to us how our data is laid out. So I'll draw it as like a table that you might have in an Excel spreadsheet or something, or a Google Sheet or something like that. And now as I draw this out, I wish I had a bigger, more, yeah, let's make it a little bigger. Yeah. And then let's go to this. It's not going great so far. There we go. Okay. So now I've got my table laid out. It's looking good. And I'm going to go ahead and make some rows in my table. Can I want to crowdsource this. Can I get a couple of songs from you all? Yeah. Just go ahead and shout them out.
She-Wolf.
Perfect.
Toxic.
Cool.
Freebird.
Can we get 4 songs?
Believe.
Believe. Who's that? What was the artist for that?
It was share.
Perfect. Cool. And then can we get some more songs from these same artists? So Shakira, Britney, Leonard Skinner, Cher.
My hips don't lie.
Perfect. I'm just gonna say, don't lie. Any others from an existing artist we already have? Maybe another Britney song?
Hit me, baby. one more time.
Perfect. I'm going to abbreviate it. Hit me. I'm just going to say hit me. There we go. Perfect. Okay. So now we've got some songs in here. So I'm going to draw each one of these as a separate row. So the table creates the tables and the column create the structure for the data. And then each row is an actual piece of data in our table. So our database would just number these incrementally like this: 3, 4, 5, 6. And I'm not going to fill in the length and the play count. That would those would just be some sort of integer values. Doesn't really matter. Just knowing that those are represented as columns. And then I'm going to draw on the right here, I'm going to draw my artist table. So an artist is going to have an ID and it's going to have a name. There we go. And so our artists we're going to have, and I'll try to like mix up the order too. So we'll say Britney Spears, Shakira, Cher is spelled like that, right?
Yep.
Who am I missing? Oh, Leonard. I think that's how you spell that, but close enough. And so now each one of these is also going to be a row. So let me ID them. So I'll ID. Just to really illustrate this, I'll give these kind of like funky IDs. Yeah. Just so it's not all like 1, 2, 3, 4. And now what I want you all to do is I want you to volunteer. What do I need to fill in on the artist ID column? What do I need to fill in the artist ID column? So we're going to do that first song first for She-Wolf. What am I going to fill in what am I going to fill in that artist ID column for She-Wolf? Can I get a volunteer? Olivia?
34.
You've got it. So assuming that you know that She-Wolf and Shakira is a Shakira song, this is going to match this artist ID, this foreign key of artist ID with this artist primary key right there. Cool. Let's keep going. What am I going to do for the next song? Different volunteer?
23.
23, looking good. What about for Freebird?
50.
Thank you. For song number 4. I'm going to start singing if I don't get a volunteer. You don't want that.
I don't know this. I don't know the artist, but if you tell me the artist, I can tell you the ID number.
It's Cher.
40.
Oh, okay, 40.
Thank you. What about for number 5?
34.
And then number 6.
23.
Great job, Kevin. All right, and so now I will just match up these primary keys with these foreign keys, or these foreign keys with these primary keys. So 23 goes to 23, 50 goes to 50, 40 goes to 40, 34 to 34, 23 to 23. And there we go. So now this is demonstrating our one-to-many relationship. You can see that for each song, and let's write this out. So let's be clear. This on the left is the songs table. This on the right is an artist table. So it's one-to-many, one song to many artists. So you can see for each one of these songs, there's exactly one arrow connected to the artist table. So that's the one side. And then for the artists, you can see that for some of the artists, there are many arrows pointing to that same artist. And so that is our one-to-many relationship. Dougie?
I guess a housekeeping question for like future projects. Was the created at and updated at columns specific to relational rails, or should we have those columns for every project? Or
You
every
should have
schema
them
that
for
we create?
for everyone. It's always a good idea to add in the timestamps. If you don't need them, like if there's no like practical reason to have it, that's okay. You just have some data that you're not going to need. That's much better than needing the data and not having the data. So we would want to be able to track when something was created and updated at, just in case we would need that later. That's just universally a good idea to have. And so that is our one-to-many relationship. This is kind of what the one-to-many lesson plan, if you remember all the way back to the beginning of last week, the one-to-many lesson plan kind of walked you through this diagram in text format. And I really wanted to circle back, draw this out for you all so we could visualize these database tables. Okay. Let's go ahead and take a pause here, and let's come back at 1:38. Come back at 1:38. All right, everybody, let's go ahead and pick it back up. And I want to start with any questions that have come up so far. Like I said earlier, very important to ground our understanding in these one-to-many relationships. What I'm going to do next is I'm going to use what we know to create many-to-many relationships. So I want to make sure we have time to clear up anything that's coming up about one-to-manys. Okay, then. Well, if there's no questions coming up, then I'm going to move forward with many-to-many relationships. So what we're going to do, or our goal, is to add playlists into our set list application. So I'll just write out in English what this relationship. So this should be a song can be in many playlists, and a playlist has many songs. So going from songs to playlist, that's a many, and going from playlist to songs, that's also a many. So this is a many-to-many relationship. Song can be in many playlists, playlist has many songs. So how do we implement this relationship? Let's start by adding in some playlists. So using what we know about databases so far, we can just, regardless of the relationship, let's just make, let's just make our playlist table. So what I'm going to do is I'm going to get rid of these arrows here. And I think I can get rid of my artist table as well. So we're going to put aside artists for the moment. Yeah. Let's take away these artists. There we go. All right. So what I want to have is a playlist table. And all of our tables are going to have IDs. So that's going to be this key over here. And then our playlists also need to have, we'll have, this will be a name. Yeah. So let me just, trying to think ahead a little bit. I'm going to move all of this over just a little bit further. And it's okay if it's off the screen just a little bit. Okay. So let's make another playlist here. Yeah, let's make, what do I want to do here? Okay, so let's make a couple playlists. So let's make a classic rock playlist. Let's make a pop playlist. Let's just call it like fave jams as another playlist. So we're gonna have 3 playlists. And let's give them like kind of funky IDs like we did before. So maybe some new ones like this. Cool. So it doesn't matter exactly which songs are in which playlist, but you can kind of imagine for yourself. So maybe classic rock would have Freebird in it. Maybe the pop has the Shakira songs and the Britney songs. So like She Wolf, Hit Me Baby One More Time, Hips Don't Lie, those could all be in pop. Favorite jams could really just be any of these songs. Yeah, so we want to put multiple of these songs into our playlists. And then we also want a playlist to have many songs. So we don't just want a playlist of a single song, we want multiple songs in there. So the first thing I want to talk about is a first guess that you might have in order to make this work. So a first guess that a lot of students have is to store an array. So our foreign keys so far have been something like artist ID, where they point to a single artist. What if instead of one number value, what if they stored multiple number values in them? So maybe something like this. Where we have playlists ID. And so then maybe we could put something for She-Wolf. Maybe this would be in 2 playlists. Maybe this would be in pop, so it would be in 59, and it would be in a favorite jam like 98, something like that. So the thought here is maybe we could connect this by this first element in this array to the pop playlist, and then the second element in the array 98 to the favorite jams playlist. So this is like our initial attempt at making a many-to-many relationship. But this, the database is not going to let us do this. So this really gives us a good opportunity to just talk about how do databases work. If we imagine our database as physical space, and it really is physical space, your computer's memory is, there's a finite amount of space on it. So when I say that if you go up to about this Mac, you'll see that it should say how much, and there's a storage section. I don't know if you can see me doing this, but it'll tell me that I have a 251 gigabyte flash storage. And so what that kind of indicates is there's 251 gigabytes for me to store something. So when we're talking about storing data, there is very much a finite amount of space that we need to consider. So if we try to make something like an array in our database, an array is a data structure that can hold an infinite number of values. So the database does not give us a concept of an array. So there are some concepts that translate over from our programming language directly to our database, like a string. We can make a string in our database, or an integer, or a float. I would describe those as kind of like the base data types in Ruby. But some things that don't translate over are arrays and hashes. So there's no way to store an array or a hash. Those are collections. There's no easy way to store collections of data in a database column. Joe?
Yeah, so is that why a lot of times we've seen when working with a database in the terminal that it's like a $sign and then number and then like limit? Is that where that comes from?
Not quite. That's more of a behavior of active record, not the database. Yeah. So something that we could do here is we could open up Postico to just look at this a little bit more. So if I open up Postico, go to, where do I want to go? Let's go to setlist development, and let's click on songs, and let's click on structure down here. This will just show me a little bit more in depth of what my database columns are. And you could see for something like, oh, I was hoping it would show us, but it actually doesn't show us here. DDL show us. Yeah, it doesn't show me here. I was hoping that it would show me, but for something like a string, character varying, there is an upper bound of how many characters you can store. I think by default, it would be 256. So maybe another way we could demonstrate this is, what if we tried to add in like a title that was too long? So if I just like hammer enough times in here, can I create 256 characters? Oh, and that's giving me some not null constraints. Yeah, this is not quite doing what I wanted it to do, so I'll just go ahead and throw this away. There's not really an easy way for me to demonstrate this, so I'll just go back to my whiteboard here. But the point is, for all of your data types, there needs to be an upper bound of how much data it can store. So for example, a string, you can only store so many characters. For an integer, the number can only be so big. Your computer can only represent numbers up to a certain point. So the implication there is that we can't store data types like arrays or hashes that have no upper bound of how many things they can store. Khan?
Hey, Brian, thank you. When you were sharing,
Yeah, I'm trying to get it back.
Okay, I don't see maybe you were purposely trying to just zoom in on the left table, but I don't see the right table. And if you intended to do that, never mind. But I don't see
did
the.
not. Yeah, this is. Let me try and figure this out real quick.
Okay.
It's
And the other table too, by the way, was like close to the margin of the right side, and I only saw the ID. I don't know if that was on purpose too, but it looked like it was cutting off. But if it wasn't, then whatever.
Yeah, I'm seeing if I can get this to share specifically on. Okay, I don't know how I did it, but now it's on the right desktop. So Con, the edge of my diagram, I'm drawing this arrow right here. Can you see those arrows?
Yes, thank you. Sweet.
Yeah, that's all you need to see. There's nothing further over to the right. Okay. Sorry about that. Zoom's giving me some trouble this afternoon. So I'll just kind of write this out in text, some of what I've been talking about. So every database column has an upper bound of how much data it can store. And I would say we're kind of venturing into nice to know territory. This is kind of like straddling the lines of like, I definitely want you to have heard this before, but if this is not like crucial information for passing mod 2, for example, but it is important just for your careers in general. So every database column, we need to have an upper bound of how much data it can store. So for example, a string can only hold X number of characters. I think by default, it's usually 256. Or also, for example, an integer can only be so big. And another way of saying that is can only be so many bytes. So the technical term for how big an integer would be bytes. Every byte is 8 zeros or ones, which is a bit. So more nice to know stuff if you're curious. A byte stores 8 bits. So if I say an integer is 4 bytes big, that means it is represented with 32 zeros and ones. We don't need to get too deep into number theory. Talking to myself, Brian, tone it down a little bit. Yeah. So the implication of this is that our DB can't store arrays or hashes because they have no upper bound. An array is just an infinitely long list of data. A hash is an infinitely long list of key value pairs. Okay, so we know we can't use this array syntax now, or this array idea. So good try, but we'll try this one more time. So playlist ID is not going to be a good column over here. So what we need to do, whoops, I took away one of my foreign keys. So what we're going to need to do in order to make this happen is that we are going to need to create a third table. And this third table is going to be called a join table. Can you all see that text, by the way, join table, as I type it? Cool. So we're going to add a third table called a join table. This table's job is to manage the many-to-many relationship. As a note here, and this will be very relevant for your solo project, it can do other things as well. So I'm going to show you today how it can be used to manage the many-to-many relationship, but you can store other data than what I'm showing you here. Joe?
Yeah, sorry. Just in terms of class, like we'll always refer to them as joining tables, right? Not like junction or bridge tables or anything.
Yeah. So what you're referring to is that these tables have other names. Junction, bridge tables. The one that I hear most commonly is associative tables. So let me just put that one here.
Thanks.
And what that indicates is that this table creates associations between other tables. What is confusing about this term joins table is that this is not the same as a SQL joins. So in your intermission work, you learned a little bit about joining in terms of using SQL statements. This is not the same thing. So I want to make that very clear. They are related and they will make use of each other, but they are not the same thing. So a SQL statement or a SQL clause is part of executing a query. What we're talking about is more of the structure of the data. So not querying the data, the structure of the data. And this table is going to have foreign keys that point to both tables in the, I'll abbreviate many to many. Another way, another implication of this is that each row from the table is the connection between two records in the many to many. So each row in our join table will be the connection of a song to a playlist. All right, so I've talked about it. Let me draw it out. So this is going to be my join table. It's going to be right in the middle. And this table, I'm going to draw it with 3 columns. Now, one thing that is important to know about database columns is that there's no real order to them. So it's not like if I'm looking at my songs table over here, don't think of it as ID is the first column, title is the second column, length is the third column. They're not really ordered. They are just columns that exist on this table and the order doesn't really matter. So what I can do here is I can actually move this ID column. Oh, I can't because it's separate. So I'll move it like this. I'm going to delete this ID column over here, and I'm actually going to move it over to the right just to make things a little bit easier on myself. So I'm going to move this ID column over here. And you'll see why I do this in just a second. So let's grab these IDs and move them like this. Order doesn't matter for the columns. There we go. Okay, so back to our join table. This join table is going to have 3 columns. One of those columns is going to be a foreign key to songs. Another one is going to be a foreign key to playlists. And then our third column is just going to be our primary key. That's just the key that we always have on every single table. So now let's start filling in this table. So every row from this table is the connection between a song and a playlist. So for my song ID, let's say we want to, let's pick a song in a playlist. So let's say, let's take Hips Don't Lie and let's put that into our pop playlist. So we're trying to connect Hips Don't Lie and pop. So what we'll do is for the song ID, we'll put 5 for the ID of Hips Don't Lie. And then for the playlist ID, we'll put 59 for the ID of the playlist. And then for our ID column in the middle here, we could just put 1. This is our primary key. And so now if I draw these arrows connecting foreign key to primary key and foreign key to primary key over here with pop, I have now connected my Hips Don't Lie song to my playlist pop, to my pop playlist through my join table. A couple other things here. So this join table is going to need a name. The easiest way to name a join table is to just kind of smush together the 2 names from each table. So we could do like song playlist, we could do playlist songs. I'm going to go with playlist songs. Just because that makes more sense to me. It just sounds better. I don't know. It doesn't really matter. Could be song playlist. Doesn't really matter. So I've done one of these for us. I want you all to think about what are the other pieces of data we could put in here. So just kind of pick a couple songs to connect to a couple playlists in your head. And I also want to, before we do that, I want to take any questions you have up to this point. Okay, no questions coming up so far. Ryan.
Yeah, I was a little thrown at first that it creates a join table from songs and playlists. And because there's already a relationship with artist ID somewhere else, we just see that songs and playlists we identify that as the many to many, and we don't really need to do anything else with the artist ID. We can get it through other ways later.
Yeah, maybe I might say that a little differently. I might say we still have a relationship to artists, but it doesn't have anything to do with our relationship to playlist songs and playlists.
Gotcha.
Yeah. So when you're looking at this database schema, and our schemas are going to continue to grow, by the time we get to the group project, we're going to have about 6 tables that we're working with. You can draw relationships between any table. So I could look at these 2 tables and say, what's the relationship between those 2? I could look at 2 other tables. So for instance, songs and artists. I could look at songs and playlists. I can look at songs and playlist songs. So we can what's the word I'm looking for? We can find relationships between any tables in our schema. It's very rare that there's tables that are not connected to anything. Yeah. So we're talking about one-to-manys and many-to-manys, but relationships really just like go as deep as you want to make them, as deep as your schema is complex. Other questions coming up right now? Well, if there's no other questions, let's go ahead and fill out some more playlist songs. So let's pick another, actually, well, I'll let you do it. So can I get a volunteer? Pick a song, pick a playlist, and walk me through how am I going to connect those 2 together? Con?
I'd like to do Freebird. So the ID would be 2 since we're doing a new one. And then the song ID would be 3. And the play. Oh, I guess that's 56.
Yeah, assuming we want to put this in classic rock.
Yeah. Thanks.
Looks great. So now if I connect these arrows, this song ID points to this song's ID. This playlist ID points to this playlist ID. So now we have associated Freebird with classic rock through our playlist songs table. And I'm going to keep saying the word through. That's another keyword. But we'll get to that in a second. Awesome. Let's keep going. Can I get some more volunteers to do just that? Thank you, Con.
Yay.
More volunteers. You just got to pick a song, pick a playlist. Risa, thank you.
Okay, so a song can be in many playlists, and I really like Hips Don't Lie. So I'm gonna grab ID number 5, and I'm gonna put it in the song ID under playlist songs. And for the playlist ID, I'm gonna put it 98.
So song ID 5, playlist ID 98. this primary key can be just 3. And so then I'll connect these. So now we've got song number 5 and playlist number 98. Awesome. So now we have implemented, now we can see one of the manys. We can see that Hips Don't Lie is in multiple playlists. See how there's 2 arrows going from this table, from the songs table, through the playlist songs table over to the playlist table. Great job, Brisa. Dougie, can you give me another one?
I will do Toxic. In the songs ID field, you'll put 2.
Yep.
In the ID field, you put 4. And in the playlist ID field, you could put 59.
Perfect. So now we'll connect 2 and 2, and then 59 and 59. So now we have demonstrated the other side of our many to many. We can now see that the pop playlist has multiple songs coming to it through this playlist songs join table. So if I follow this arrow all the way through, it goes from 59, 59, 5, and 5. So I've got Hips Don't Lie, and then same thing over here, 59 to 59, 2 to 2 is Toxic. So we've got Toxic and Hips Don't Lie in that playlist. There we go. So the final thing I'm going to do here is write down what I've been saying with through. So when it comes to one-to-many relationships, Joe walked us through how the keywords are has, many, and belongs to. In terms of songs and artists, song belongs to an artist, artist has many songs. Now with a join table, we have a new keyword called through. So we'll say for our songs, a song has many. The first thing I'll do is I'll say it has many playlist songs. So that's the first part. A song has many playlist songs. So the relationship from the songs table to the playlist songs table, we can see that every single playlist song is pointing to one of our songs table. So that tells us that every single song could have many playlist songs. The other side of that relationship from playlist songs is that a playlist song belongs to a single song because it has that song ID foreign key. Looking at the relationship between playlists and playlist songs, a playlist song also belongs to a playlist because it has a playlist ID. So every time you have a foreign key, you belong to, every time a table has a foreign key, it belongs to that table. So a playlist song belongs to song and belongs to playlist. And then looking at a playlist also has many playlist songs. So that's everything that we've seen before. We have has many and belongs to. This is where our what I was saying when I said ground our understanding in one-to-many relationships. We're still using the one-to-many relationships, and now we would add in a third key or another keyword here to tell it what the relationship is between songs and playlists. So the relationship from a song to a playlist is that a song has many playlists through our join table, which is playlist songs. And a playlist also goes through that join table, but it has many songs through playlist songs. So now that we have 3 tables in our many-to-many, we have a relationship between each one of those tables. So we actually have 6 different relationships, from songs to playlist songs, from songs to playlists, from playlist songs to songs, from playlist songs to playlists, and from playlists to playlist songs, and from playlists to songs. 6 different relationships. And so when you, now I've kind of started pseudo coding in my diagram. When you get into coding this in your model, these are the lines that you're going to have in your models. Specifically, these are the new associations you're going to make. And that's really all the content that I have for you today. So yeah, what I want to do for the rest of the class is to take your questions and have you all continue to work through that tutorial section of the lesson plan. So if you haven't finished that already, go ahead and keep working through it. I'm not going to move you all into breakout rooms just because I think we're probably all in different places of that tutorial. So I'll just kind of leave this call open and do questions. Let's go to Andrew.
Yeah. So when I'm looking at this, it seems to me that we hardly have any use for the middle column of play songs, the ID, because all we're really doing is saying, you know, these two things are connected. Why do we need to have like a whole ID that is associated with that when all we do is connecting two things, and each connection should on its own be pretty unique?
Yeah, that's a good point, Andrew. We're really not making use of that primary, just to be very clear. Andrew is talking about the primary key in the playlist songs table. So this column right here. Yeah, that's a good point. We're not really using that. That's just kind of the default behavior of Active Record, is that every single row needs a primary key. So that's just kind of how our database works. We always have a primary key. And in the future, that this kind of goes to this point that I've left intentionally vague. There are some cases where we do actually need to refer to one of these records individually and do some things with it. So even though we haven't seen a use for it yet, there might be a use in the future. So might be a use for it in the future, and this is just how Active Record works. Let's go to Ryan and then Dougie.
My question goes a little bit more to the actual lesson. Is it okay to ask a question over there yet?
Yeah, I think so. Let me check in with Dougie first. Dougie, do you have a question on like this diagram before we get into the code?
Yeah, so just concerning the note that we made about databases having an upper bound of how much data they can store. When going through a join table, we're dodging that limitation, I guess, is my understanding. Like we can have as many playlist songs as we want and as many songs in playlists, and I'm sure you get what I'm saying.
Yeah, you're right. We are getting around this. So I want to highlight here that I said every database column has an upper bound of how much data it can store. So what that's pointing to is for each one of these columns, we can only store X amount of data in it. But what you're pointing out, Dougie, is that we're getting around it because there's no limit to how many rows we can store. So rather than storing additional data in a column, we just create a new row to store that data. So no limit to how many rows our tables can store. Let's go ahead and talk about Ryan's question. So Ryan, should I screen share the lesson plan? That would probably be best.
Yeah, it's on the playlist index page part of the lesson where it's in the RSpec. They're like almost at the bottom.
Let's just go up from the bottom.
Yeah, so the line where it says it has purple equals uplifting songs. So if you scroll up a little bit more. Yeah, right there. I'm a little bit confused as to how it can create a song from a playlist. It's not using an artist there, but in the title, Purple Rain, length, play count, it has artist Prince. So it's linking Prince with the Prince that is a variable up top. And this wouldn't work if that wasn't Prince, right? Like if you put a different artist name there, would it throw an error?
So if you put like, rather than this variable, which refers to this object, if you
Right.
put like a string here for like the name is Prince, is that kind of what you're asking?
Yes.
Yeah, that would not work. So when we use an association to create something, let me say that, let me start over. When we have a record like a song, so notice we're doing a songs create, and a song belongs to an artist, we need to tell it which artist record it corresponds to. If you put a string in here instead, it would say expected an artist, but got a string instead. So active record would be smart enough to catch that error for you.
Okay, that makes sense.
Yeah, this part of the lesson, I would say, so this is like at the very end when we get to playlist index page, this is a really good thing for you to understand. So what I've done in here is I've done things many different ways. I've created a playlist one way, I've created a song and associated with the playlist another way, I've done it another way, I've done it a fourth way, I've a fifth, sixth way. So I've done it a bunch of different ways. So in terms of you all studying, this is a very useful tool for you to kind of test your understanding. Can you understand what each one of these different syntaxes is doing? And there's some comments in here to kind of help you along. I'll just stop sharing for now. If you need me to share the I'll drop the diagram in your channel as well. But if you need me to go back to it at any point, just let me know. Any other questions coming up for you all so far? Con?
Are we utilizing the many-to-many concepts for our IC coming this Monday?
Yes, yes, you will be doing that. So for your independent challenge on Monday, we're going to ask you to set up a many-to-many. That's going to be the key. That's going to be the key focus of the independent challenge. So the best thing that you can do to study for that is to work through this lesson plan and maybe review. This is one of those, this is a very important lesson plan. So I would expect this is one you have to work through a couple times and really solidify the content in there. And then Con, do you have a follow-up?
No, no following.
Okay, thought I saw your hand go back up. Does that, I guess that answers your question.
Yeah, thank you so much.
You're welcome. I did drop the copy of this diagram into the into your code help channel. Cool, cool, cool. So I think what I'm going to do for probably the next maybe 30 minutes or so is let you all continue working through that tutorial and ask any questions as they come up, and we'll check back in at the end of the class, see if there's any kind of final questions. If you finish early, work through those checks for understanding, and yeah, we'll kick off your project shortly. So for now, let's say let's do individual work time until 2:50. We'll come back together, and if you have any questions before then, just feel free to let me know.
Could I ask a question really quick?
Absolutely.
Well, I guess it's more of a, is this how it's supposed to look? Let me try and share my screen. Make sure I got no weird tabs up. All right. So like, kind of like, and don't mind these other ones. These are just my personal notes or whatever. But would it essentially would our schema essentially look like this for a many-to-many relationship?
Playlist songs, song ID, playlist ID. Yep. Pointing to playlist ID. Yeah, you got it.
Okay, all right. I just wanted to make sure I had it.
That's great.
Hi, Brian. I had a couple kind of general questions, I guess.
Yeah, what's up, Kevin?
Yeah, so at the top of this many to many relationships lesson, it said this lesson builds off the passing the data lesson, and to find the code on the passing data branch of the repo. Is
Mhm.
that one repo for setlist the same completed? Is that same completed repo for setlist that we use in all the others?
Correct. Yeah, there's only one main copy of that set
Okay.
list.
Okay, and then we're just we're just doing a checkout of the specific branch that we want to be working with, whether it's the class one or the passing data.
Mhm.
Okay.
Yep.
Yeah, that's why I suspected. Just want to double check. And then I did run the bundle exact R spec in it, and it says, yeah, there's 100% coverage, 13 examples and 0 failures. Does the 13 examples refer to just, is that the number of tests, or what are the examples?
Yeah, so that's the number of tests, and in our spec, that's specifically the number of those it blocks that you have. So it
Okay.
does something. Yeah.
Okay.
Yep.
Great. Thanks a lot for that clarification.
You're welcome. And another thing that you can think about is that unlike mini test, our spec doesn't tell us how many assertions we have. So mini test is really nice where it will say like 10 tests and 23 assertions, right? Is that ringing some bells? If I
Okay,
remember
yeah.
mini test correctly, our spec doesn't have any notion of that. So with examples, it just shows you how many tests. It doesn't tell you anything about the number of assertions.
Okay, yeah, that makes sense, because there could be a lot of different expect to have contents within that single block. There could be many assertions, I guess you could say. So
Exactly. Yep.
Yep. All right, that makes sense. Thank you.
You're welcome. I just dropped this note into your cohort channel, but just so you also hear it, come back together in about 10 minutes at 2:50. So work for 10 more minutes.
Hey, Brian, I have a quick question.
Yeah, let's hold up on it for a couple more minutes, Ryan. We'll come back together in just 2 more
Okay.
minutes. All right, everybody. Let's go ahead and come back together, and we'll start off with well, actually, before we do questions, I just want to do some polling to see how far you all got. Can I get a hand raise reaction if you were able to work all the way through all the code in this lesson? So hand raise if you got through all the code in the lesson. Cool, so we're probably at about half, which seems about right to me. Highly recommend that you all finish working through this lesson plan, and probably that you work through it maybe a couple times to really emphasize these concepts. This is one of those lessons where if you don't really understand what is going on in the lesson, it's going to make it very difficult to work on your project. So I would say even before you start working on the project, really make sure you're solid on many-to-manys. All right. Brian, you had a question for us?
Yeah, I worked through it and I expected the test to pass. And it's just, I've just been stirring around for about 15 minutes trying to get this test to pass. And it's saying that the active record validation failed, playlist must exist. And I don't know why it wants a playlist to exist when it's trying to create a song.
Interesting. Let's can you share your screen? Let's look at it together.
Yeah. So this is it's when it gets to this line, talkingheads.songs.create, and like the real curious thing to me is like, why would it matter? Because it's not even talking about playlists until further down in the test.
Yeah, that's interesting. Playlist index spec line 9. So here's this is like kind of a theme with a lot of my lessons, but there's a lot of like, oh, this is a good place to talk about X, which we don't necessarily have a lesson on. So let's talk about debugging a little bit. When I see this error output, I really want to be clear about like kind of where my eyes go. The very first thing I look at is this stack trace right here. So this is going to tell me the exact line of code that produced this error. So this is pointing me towards this line in our index test, line 9 in our index test. So reading stack trace and figuring out what the exact line of code is is a key first step in debugging. Okay, so we have talkingheads.songs.create, and then it says validation failed, playlist must exist. Jameson is going to talk to you all about validations on Monday, but this will be a nice little sneak preview. So if we're trying to create a song, I see we're doing songs.create, and it's saying the validation has failed. I would go to look at my song model to see if there's validations there. So can we open up the song model? Yeah, and there's our issue right there. So it says belongs to playlist, but a song does not belong to a playlist. As we talked about in the lesson, the relationship here is many to many. So when you have belongs to, that's indicating a one-to-many relationship or even a one-to-one relationship. So yeah, I would say our models are not quite where they should be. Can you split the screen? So that's not quite going to work. Can you split the screen with the 3 models? Let's do song, playlist, and playlist songs.
So song, and then you wanted to split like 3 ways. So
exactly.
So song on the left, and then you want playlist here, and then playlist song.
Yes.
Okay.
Cool. So this is looking good. Yeah, our playlist has many playlist songs, and it has many songs through playlist songs. That looks right. Actually, maybe we could do this. Could you flip the order of, could you move playlist song to the middle and playlist on the right? Just because that will correspond with how we drew the diagram. So we had song on the left, playlist on the right, playlist song kind of sitting in between the two. So I'd say these 2 relationships for going to playlist song and a playlist look good. I would expect to see those corresponding something very similar over here in my song model. I want to look at my lesson plan. Does it walk you through setting up the song relationships?
I did this one. Has many playlist songs, and so that's the last one I did.
Yeah, so that part, a song has many playlists. So I think you missed something in there.
Did I miss this last one? A song mod?
Yeah, exactly. So this is walking us through adding in the relationships to our song model. So yeah, you can just copy those and put them right in there. So you started off with belongs to playlist, which was not quite right. Then you moved to has many playlists, but we can't go directly to playlists from songs. We need to say that we go to playlists through the join table.
All right. Yep. Yeah, sorry, missed that.
You're good. Let's run the test again and see if we get something different. And there we go. Now we're passing.
Great. Thank you.
You're welcome. Other questions, other things that came up as you were working through that. Keegan, did you have something for us? Cool. Other questions that came up during that? All right. If not, I think we can kind of wrap it up there. So this is the last time that we'll have class together until Monday. So very much recommend that you all work through this lesson some more and kind of use it as a study tool. Yeah. So let's go ahead and talk about our next project. So let's go to backend.turing.io, module 2, projects. So our next project is going to be adopt, don't shop. And I haven't looked at this schema yet. Let me look at this. Pets, shelters, veterinarians. Yep, perfect. So what we have here is we have Jameson was kind enough to go through the last relational Rails project and create a starter repo. So you can think of this this project as building off of the last project. So these existing tables that we have in here are shelters and pets and veterinarian offices and veterinarians. So what we're going to do is we're going to use that shelters and pets relationship to, we're going to build off of that, and we're going to create a pseudo pet adoption platform. I say pseudo because we're not going to like fully build it out, but we're going to build out a lot of functionality for allowing users to apply for pets and adopt them. So you can use this repo as kind of like an somewhat of an answer key from the last project. So something like, oh, the nested route for pets was really difficult, or the parent-child create was difficult. And so we could come in here and we could see what that might look like. So there's a lot of good completed code for you all to reference in here. But let's talk about what you're going to be doing in this project. So our key learning goals of this project are, the first one here is build out CRUD functionality for a many-to-many relationship. I would say this is like the first part of the first really key goal that we are adding into this project. So many-to-many relationships, very, very important goal for us. The second learning goal here is to use active record queries to join multiple tables of data together. So we're going to have a class on joins next week. You all learned a little bit about joins in your intermission work. Now we're going to start talking about that in class, talk about what that looks like in terms of active record and how we can really use that in our project. I think a lot of you did a good job with this in the first project, but we're going to emphasize a little bit more about code organization. So specifically separating out responsibilities between our model, our view, and controller. And specifically, we want to limit what is in our views and controllers and push more logic off to our models. Then we're going to get into validations for SAD paths. We're going to talk about flash messages. We're going to talk about partials within blocks and tests. This is going to be part of your exploration tomorrow. So this is all some like new Rails concepts that we're going to layer on. And then the last two here are a little bit outside of Rails. So the first thing is track user stories using GitHub projects. So you might have already done, I think you all have used this a little bit in Mod 0, but GitHub projects is going to be our project tracking tool. We really want to get you all started with this in this project, which is going to be a solo project, so that you are prepared to do it as a larger group on your group project. So start doing some of it now so that we can really hit the ground running with a group project. And then the final thing is deploy an application to Heroku. I'll kind of do a mini lesson on Heroku at the end here. For your check-in, we're going to have one check-in for this project. The main thing that we want to look at is the database schema for the many-to-many relationship. And then we're also going to check in on some of those new concepts of Heroku and just using the GitHub project board. So just to re-emphasize how important the many-to-many is, we're going to want, that's going to be the first thing we want to look at when we meet with you all. Here's our rubric. As always, make sure that you're reading the rubric to just kind of keep your eye on what we are expecting from you in terms of your evaluation. The next part here is what your eval is going to look like. I think that we might go through and update some of this. Yeah, we might update some of this, but the overall idea is going to be the same for this evaluation. So we're going to ask you all to present certain parts of your project and discuss each of the rubric categories above. So specifically, we'll want you to do things like show your project board, show us Heroku, show us your routes file, et cetera, et cetera. So Jameson and I haven't had a chance to talk about this, but most likely we'll go through and update some of these specifics on what we want you to present in the eval. We don't really expect you to prepare anything before late next week. So you don't really have to worry about this too much, but just want to make a note that we are going to ask you to come to the eval prepared to talk about a couple specific items. Yeah. So before I get into the user stories here, I want to, what do I want to do here? I'll talk about the user stories a little bit. So the first one is deploy to Heroku. I'm going to save talking about this one until the end and do like kind of a mini lesson on it. Apply for pets. So this is kind of like the starting of the application process. So in this, what this application is going to look like, or sorry, what this Rails app is going to do is it's going to allow someone to come into this website, view some pets, and start an application for adopting those pets. So this is the start of our many-to-many relationship. In this project, it's going to be between pets and applications. So you can apply for many pets, and pets can also be applied for on many applications. So that's going to be your many-to-many. So we have an application show page here. We have a starting an application page here. And then we get into a little bit of sad paths. So sad paths are something we haven't talked about yet, which is when things don't go as expected. So for example, your user doesn't fill out your form completely. How do you handle that? We will have a class specifically on sad paths and flashes next week. But notice that this is the, what is this, the fourth story here. So some of these stories you're probably going to get to before we have the class on them. Searching for pets on an application, you can add pets to an application. So I'm not going to go through all of these stories individually, but I want to talk a little bit more about the process of working on this project. So this is a solo project. It's going to be a 1-week project, and it's going to be due on Thursday night. So you're going to have from now until next Thursday, so exactly 1 week to work on this project. So we do expect that you all are making a pretty good amount of progress on this over the weekend and Monday before we get to our first check-in on, which is going to be on Tuesday afternoon. So the biggest piece of advice that I have is to avoid unproductive struggle. And another way of saying that is avoid a scenario where you get blocked for an extended period of time. So for example, this form not completed page right here directly relates to our sad path and flashes class, which we are going to have on where is that? Oh, I'm looking at the wrong week on my calendar. Excuse me, which we're going to have on Tuesday. Yeah, so we're going to have that Tuesday during the day. So it might be very likely that you get to this story and you can't quite complete it. And you might say, oh, I tried it, but I couldn't quite get it. I need the lesson before I can move forward. What I really, really want you to avoid, and what students often fall into, is they get to this point and they say, oh, well, I can't complete this story. I'm going to stop working on the project. And you really need to push through some of that difficulty. So what I mean by that is if you get to this point, go on to the next story. And if that story you can't complete, go on to the next story. These stories do not necessarily have to be completed in order. Some of them you might need the code from another story before you can move on. So some of them might block you, but some of them might not. So it's really up to you to look at a story and see, can I work on this story? And if you can, work on it. And if you hit a point to where you're blocked on it, do your best to get out of that unproductive struggle, but also know when it's time to reach out for help, and also know when it's time to move on to something else. So don't spend all of your time trying to do all the stories in order. Go on to another story if it's not working for you. We really want to make sure that we don't get to Monday and have very little of this completed. You want to try and complete as much as you can over the weekend. Doug.
So if we say get to that fourth user story with the sad path blockage, and we reach out before the lesson, are we just going to be told this we'll cover this in class on Tuesday, or like how does, you said reach out and ask for help? What does that look like if a lesson hasn't been taught yet?
Yeah, what I meant is just like use any of your resources. So that could be, I think your most valuable resource is each other. So if you all could ask each other in the code help or something like that, that would be ideal. Mentors are another resource that you can reach out to. Upper mod students are another resource. And you definitely can reach out to us as instructors. It's just that there are many of you and only 2 of us. And so it's just more likely that you'll get your question answered quicker if you reach out to one of those other resources. It might be the case that we might say like, oh, we'll cover this in class. What I will say is that the more specific your question is, the easier it is for us to answer. So if your question is something like, how do sad paths work? That's going to be very hard for us to answer. Versus if you ask something like, for a sad path, how does that relate to validations? That's like easier for us to answer. George.
For the user stories, are you expecting us to break apart each component that goes inside each user story? Or do you just want it to be like one ticket is one user story?
I think each one of these is a single user story.
Okay.
I believe all of them do a good job of not putting too much into a user story, like multiple features into a user story, but it's very light. It is definitely possible that you're going to have to write more than one test for each user story.
Yeah. And then
Is that what you're
for
getting
like
at?
how much we're graded, I think GitHub projects is kind of like Trello. So you just want us to create like a ticket for each one and drag them over whenever we finish them, right?
Yeah, I'll get to this in a second, but you don't have to create the tickets. We've already created them for you.
Oh, okay, perfect.
Yep. We'll get you a copy of our project report.
Thank
I'm
you.
kind of holding off on that. Yeah, other questions that have come up so far? All righty then. A couple things I want to point out here. So there are some of these you might find the order a little bit off. So for example, this whole first section deals with applications. And then there's this section called database logic part 1. And then it gets into shelters here. And so we do kind of shift gears maybe a little awkwardly in the middle of this project. This is really, Jameson talked a little bit about this in the first project, but we really want each phase of this project to be a spiral of understanding. So we want you all to get a full slice of the project. So the project used to save this database logic for the end, but what we found was that students who didn't get all the way to the end missed out on that learning. So that's why, in case you're wondering about the order of the stories, that's why they're laid out the way they are. So the idea here is that between this first section and this database logic section, that should hit all of those learning goals I discussed earlier, which is your many-to-many, your joins, your sad paths, your validations, all of those. To get a 3, what we've said to get a 3 on this project is to get all the way through this approving application sections. So these first 3 sections. So you'll notice that there is a lot of wiggle room for getting a 3 on this project. There's a whole lot of stories that can be completed after that kind of passing point. Khan, did you have a question?
Yeah, I just realized I had a question earlier when you said reach out to your resources. I thought I was under the impression somewhere that mentors could not help with projects, or was that for the ICs? I don't remember. Do you have any clarity on that?
Yeah, I think typically we don't want your mentors helping you out directly with the project. Now that doesn't mean that the mentors can't help you with concepts on a project. So for example, I think that it would be totally fine to go to a mentor and say like, I'm really struggling with this story and I can't figure out what it is that I don't like. Can you help me identify where I have a misconception? That might be an appropriate thing to talk about with the mentor. Now, what I wouldn't want is for you to be driving, your mentor to be navigating, and your mentor telling you what code to write in your application. So that's kind of the difference there.
Got it. Thank you.
You're welcome. Ryan?
Yeah, could you mention one more time the specifics of that first check-in? Are you really testing to see that we understand the relationship between a many-to-many and how it like pertains to like the way our MVC is kind of set up?
Where is this check-in? Here it is. So review your database schema for the many-to-many. So it's not so much anything to do with like the controllers or other parts of the application. We really want to talk about the database level design of a many-to-many, which is very, very similar to that diagram that I drew for you in the many-to-many class.
Gotcha.
Yeah. And so you don't need to like make a schema design like you did for the last project. We can look directly at your schema.rb file. Let's go ahead and talk about the projects. So I'm going to use conveyor belt to copy over this project board for you all, and I'll go through that later. But for now, I just want to show you what your project board is going to look like when you get it. So you're going to have these 4 columns, and you're going to have 27 stories in your to-do, which match up with, if I go back to the main project side, which match up with the stories listed in the README here. So this README is nice to have kind of like all the user stories in one place. And there is some additional information in here, like this sentence right here and these headers. So like this section for apply for pets. And you'll see that our rubric references these sections. So it says all the stories in the apply for pets section. So you can use this README to look at those individual sections. But then when it comes over to the project board, you're only going to get the title of the story and the text of the story. So this is probably a better example. So title of the story, starting an application form not completed, and then the text of the story right here. Additionally, the extensions at the bottom here are not listed in the project board, so that's what else you can use the README for. So these 27 stories here represent all of the user stories that we want you to complete. You don't have to complete all of them for a 3, as I mentioned earlier, but all the user stories are listed here. In order to complete a story, we've got 3 different columns here. So we've got in progress, merge to main, and deployed. So I'll talk about deploying in a second, but what this indicates is that a story is not fully done until it is deployed. So in progress is like you're working on it, you're writing the tests, you're trying to make the test pass. Merge to main is you've made all your tests pass, you've submitted a pull request, you've completed the pull request, and it's all merged into your main branch. The final step that we're going to add on that you haven't been doing so far is that you then need to deploy to Heroku. So this user story is not great because it's a deploy story, so this is probably a better one. I'm working on the application show page. I make the test pass. Okay, cool. I submit my PR. I merge it into main. Now it's here. And then I deploy to Heroku and I make sure that it's working on Heroku. So really, really important. A story is not done until you've deployed it. There are some other cool things you can do with this project board. So for instance, if you hit like this plus button here, you can add a note for yourself. So I can say like refactor note, go back and look and refactor I don't know, pets controller, something like that. You can add in your own notes here. It's not necessary that you do that. The key thing that we want to make sure that you're doing at this point is you're using this to track what stories are in progress, and then what stories have been code completed, and then what stories have been deployed completed like this. So that's the base of what we want you to do. It might feel a little, it might feel like kind of unnecessary to use this project board for a solo project, but we really want to make sure that you are familiar with this project board before we start using it more extensively on the group project. So if I flip back over to my rubric here, sorry. We do have a section on the rubric for project management. And so what we're looking for a passing project is that you're using it to track your user stories, and that it's up to date at your check-ins, and that it's fully up to date at your evaluation. So every time we meet with you, we should see that your project board is indicating how far you've gotten on the project so far. What we really don't want to see, and I do get notifications whenever you move stories, what we don't want you to see is that you work on the project, and then at the very end, you go in here and you're like, okay, I'm done. I'm just going to move all of these stories all the way right over here to the deployed section. That is not how we want you to use this project. We want you to move them across the columns as they move between each stage. I think I saw a couple hands up. What questions do you all have so far? Aiden?
We'll still be able to use localhost for this, right? So I'm kind of imagining we merge to main, check it out on localhost, make sure it works right, and then you deploy it after that. Is that accurate?
Correct. Yeah, and I'll talk a little bit more about your different environments like localhost in my mini Heroku lesson.
Thank you.
Andrew?
Yeah. When are we going to be learning about Heroku exactly?
In 10 minutes.
Okay.
Dougie?
Are these cards? Are the cards on the GitHub projects board? Are they automatically linked to PRs? Like if I put in a PR number, card number, blah blah blah, completed or whatever, is it automatically going to move over, or are we manually going to have to do that?
There is a way to set up the automation, and it can be nice to have. I personally don't like to set up automation, so I don't really like it when things automatically move from here to here. I would much prefer to go in and as a human say, yes, I have completed this thing, rather than letting my PR kind of move it. That's my personal opinion, but if you want to set that up, you certainly can. I don't know how to do that. There's definitely a way to do that. Yeah, I'm not sure. George?
Do we have to make PR since it's a solo project?
Yes. Yes, PR should be part of your normal Git workflow. Now, the PR can be as simple as I push my branch, I make my pull request, and then I merge it immediately. You don't need to like fully document your PRs, but you should still be submitting PRs and merging them. Con.
Hey, so then we're making, so I'm cloning this, I'm forking this adopt own shop, correct, to my own repo?
The forking will be done for you. So you are going to have a fork, but our conveyor belt app will automatically fork it for you.
Oh, okay. And then, so then when I'm when I'm moving these cards and transitioning from in progress to main, although I'm making my own personal PRs on my repo, when I'm here in this project, these are PRs that you all are seeing and being notified of as we make our progress to our project?
So so you're going to have your own copy of, so a fork is going to be your own repo. So rather than Turing School examples, it's going to be whatever your GitHub username is. So
Yes.
like cons GitHub /adopt_don't_shop, and you're going to see this project. What I was referring to was that because your project, it's a little bit too technical detaily, but my GitHub user account is going to be directly linked to your repo. So I will get notifications every time you move one of these cards. That's what I was saying.
All right, so don't sandbag and do all the moving the stuff at the last minute, because
yes,
you want us to learn this process.
Yes. Yes,
got it.
Exactly. Yep. Learn the process, and it's not so much that you need to have this specific process, just that you have a process for tracking what you're doing. Dougie?
Just for clarification on Khan's question, are we cloning this or are we forking this?
You are forking, but you don't need to manually fork. Our app will automatically fork for you, and then you can clone your fork.
Okay, I'm a little confused about that then. Like how?
Yeah, that's okay. Don't worry about it. We'll do that at the end. Yeah, we'll more to come. Okay, a couple other things I want to mention before we get into the Heroku side. You will see that some of these stories will be marked SQL only. And I believe there's only one for the base requirements of this project. But I just want to point out that you will see this. So there is a special active record method you can use called find by SQL. And there are some docs here that show you how to use this. I mentioned this before in the SQL and active record class, but understanding SQL and what's going under the hood, understanding what's going on under the hood of active record is very important. And so we do want you to kind of follow these instructions of this story. So you will see a couple of those. I think that's everything except for Heroku. So let's go ahead and take a 5-minute palm, come back at 3:30. And when we come back, we'll talk about Heroku. All right, everybody. We're going to get started back up. I do want to thank you all for sticking with me. I know that this is a long day, long afternoon. Normally, we wouldn't want to do this much in an afternoon, but just with us being out tomorrow, it does make things difficult. So thank you all for your patience and bearing with me. And let's go ahead and finish it up strong. All right, so let's talk about Heroku. And more specifically, let's talk about our environments. So I want to start with your development environment. So we've thrown around words like local host. Let's talk about what that actually looks like. So I'm going to draw a diagram, which I draw pretty often, which is going to be our client-server relationship. So on the left here, we've got a client, which can more specifically be thought of as a web browser, especially in Mod 2. So this is someone is using their web browser to send HTTP requests over to our server, which is more specifically our running Rails server on the right. So we write all of our code, we run Rails S, and that is creating a server that's waiting to process requests. So when the web browser wants something, it will send an HTTP request over to our server like this. Our server does some things, processes the request, however it processes it and sends back an HTTP response like that. So that's your quick overview of the HTTP request response cycle. And this is just like kind of how a Rails app works. So you have a couple different environments in your Rails apps. So the first one I want to talk about is your development environment. Let's actually do this. Let's just have notes for a development environment over here. So for your development environment, this is your local host route right here. So whenever you're visiting localhost, you are working in your development environment. Additionally, this is your Rails console. So when you run Rails console, that is running in your development environment, and your Rails console allows you to interact with your development database. So the convention is your app name _ development. That is the name of your dev database. So the name of your development database. So we mentioned it very early on, but you do have two different databases on your computer. You have your development database and you have your test database. So development database goes with the development environment, localhost, the Rails console. Those are all part of your development environment. So this is my general diagram. Let's talk more specifically about what does this look like in development. So when you're in that development environment, well, this is more specifically not just a web browser for the client. This is a web browser on your computer. So I just want to be very clear, that's you opening up Google Chrome on your computer. This HTTP request it doesn't actually go out into the internet and go through all of the so remember that diagram that I showed you on day one of the connection of fiber optic cables and everything. This HTTP request doesn't actually go outside of your computer. So this actually goes to localhost, which is known as the loopback address. So it's called loopback because rather than going out into the internet, it's essentially sending a request from your computer to your own computer. So then this Rails server is Rails S. More specifically, this is Rails S in the terminal on your computer. So when we're working in development, when we're sending HTTP requests, when we are accessing the database, all of that is happening on our computer. Nothing, there's no external things going on. We're not going outside of our computer on. Everything is local. Any questions about that so far before I move on to test? Okay, so the next environment is our test environment. Actually, let me snapshot this first before I move on. Cool. Okay, so our next environment is our test environment. So the way that we kind of get to our test environment, rather than going to a web browser and visiting local hosts, we access our test environment by running our test. So this is bundle exec rspec, I would say, is what kind of initiates that test environment. The database is your app name and then underscore test. So this is name of your test database. So you have a separate testing database. So development database connects to the Rails console and working with it in localhost. And I guess one other thing that I could throw over here into my notes on the left here for development is this is your Rails S. This is you running your Rails S. So the way I would initiate development environment is by running Rails S. The way I initiate the test environment is by running bundle exec rspec. So let's clean up our diagram a little bit over here. And let's do this again for the test environment. So in test, our client is now, rather than us using a web browser, our client is a headless browser, which is Capybara. So Capybara is now the client. Capybara is the thing that is using our application. So we are our tests are essentially programming this headless browser. It's almost like a robot. We're programming a robot to use our application. So we say, hey, robot, visit this page. Hey, robot, click on this thing. Expect there to be this thing on this page, et cetera, et cetera. Our server on the right here is still going to be a running Rails server. It's just that we don't manually run that server. That server is automatically spun up by our executing test. So those are the two environments that you are most familiar with so far, your development environment and your test environment. A couple things you may or may not have run into so far. Sometimes with certain commands, you might need to specify which environment you're working with. And the way that Rails does that is with a flag called Rails env, or maybe a variable is a better word for that. So I could say something like Rails env equals test. So if I need to migrate, but for whatever reason, my test database isn't migrated, I can run Rails db migrate and add in Rails env equals test. And this command would say migrate only the test database. So Rails db migrate by default should migrate both of them, development and test. But if for whatever reason it doesn't migrate test, you can use this to tell it to migrate just the test database. Or I could change it to Rails db drop to say only drop the test database. Any other questions before I move on to our third environment, which is production? Con?
Brian, you're gonna save this and send it in the code help channel. Is that correct? Afterwards, the image?
Yes.
Sweet, thank you.
So up to this point, with the environments that we've looked at, everything is still just happening on our computer. The database is stored on the computer, the server's running on the computer, our browser is on the computer, either our actual Google Chrome browser that we're using or the Capybara headless browser. Everything is still just happening on our computer. In our third environment, that is not going to be the case. So production is the exciting environment, the more interesting environment, where we get things out of our computer and get them onto the internet. So maybe I'll just note that here. This is when our app runs. This is when our app maybe is accessible. It's probably a better word. This is when our app is accessible on the internet. So production is like you're actually like putting on the show. If you think about like the production of a play, well, we're actually like putting on the play, we're putting on the show. Production is like we're real life, we're running, people can actually use this application. So some key points about working in production. The database, maybe a better way to say this is you should be careful when working with production data. This is probably the most important point of production. Production is your real life running code. And so we don't want to be casual with our Rails commands. So I've kind of shown you in class, oh, if I'm cloning down setlist and I just want to like get it set up for practice, I can just drop the database and recreate it and migrate. That is not true with production. If you just drop a production database, you just be dropping all of your data. So if I'm talking about Facebook's production database, if I drop that database, then I'm dropping real life user data, which is bad. Now, if you're smart, and not you as in like right now in mod 2, but if you're a company and you're smart, you're backing up your data so that if for whatever reason your production data does get dropped, you have backup copies of it. That is a smart thing to do. But you still want to be careful when working with production data. Now, a lot of times when you are on the job, you'll actually have a fourth environment called staging, which is kind of in between development and test and production, so that it's almost like a about to be in production state. So rather than going straight from your local to real life running app in production, there's another checkpoint along that way. We're not going to get into a staging environment at Turing. We're just going to have these three environments. In our production database, the convention is just app name is the name of your production database. So if we're creating a adopt-don't shop, that database will be called adopt-don't shop. Let's talk about the other components that we have here. So now we're not working in test, and let's redo our client-server interaction. So now in production, our client is any web browser anywhere in the world. This is where our applications now have power. We are now connected to anyone who wants to use our application anywhere in the world. So that's going to be the goal of this project. You will have a link that you can send off to your mom, your grandma, whoever you want, and they'll be able to go visit your application. As long as they have an internet connection, they will be able to connect to your application. So something else that I will draw here to really hammer home this point is now that we're sending HTTP requests, they're not just staying within our local computer, they're going through drawing skills. This is a cloud. You know it's good when you have to explain what it is. Our requests are now going through the internet. So think back to that diagram that I showed you on day one of our fiber optic cables. When a client is sending this HTTP request, it's going to be routed through a lot of infrastructure, routers, fiber optic cables, all of these things to get to your application. So now on our right, our server is still Rails S. It's still a running Rails server, but now it is running on a remote Heroku server. So this is some server hosted not in your computer. It doesn't really matter where it is. The important thing is that it is not local on your computer. Could be in the United States, could be in China, Japan, could be in India, who knows? We don't really care. It's just somewhere out there on the internet. So going back down to my notes here on production, the terminology here would be Heroku hosts our applications running in production. So Heroku is our hosting service. Now, if you're curious about things like DevOps and you've heard about like AWS or maybe competitors like Microsoft Azure, there are more maybe complex ways of deploying an application. The reason why we use Heroku is because it's pretty straightforward. It's relatively easy. Now, as students, you're going to be working with Heroku, and there are going to be things that don't seem very easy about working with Heroku, but it really takes a lot of the details away from you. So for instance, like you don't need to register for a domain name or anything like that. Heroku will just automatically give us a domain name. So those domain names that these HTTP requests are going to be sent to will look something like your app name dot Heroku app.com. So your mom, your grandma, whoever will be able to go to Joey's adopt-don't-shop.herokuapp.com and see that application running in real time. Some other things about the production environment. So because this is now running on a remote server, we have to interact with production remotely. So rather than running Rails DB migrate, our database works just the same like it does locally. We're still going to need to migrate it. Rather than running Rails DB migrate on our local computer, what we're going to have to do is tell our remote Heroku computer to run Rails DB migrate for us. So as we interact with production, we are starting to send commands across the internet to some remote server somewhere to run these commands. And I'll just give you an example of that. Rather than running Rails DB migrate, we'll do something like Heroku run Rails DB migrate, which is a command that says, Heroku app, run this command. And I think that's about all I need to cover here for the production environment. Yeah, what questions do y'all have? Joe?
Yeah, since these are going to the internet, what if somebody actually wants to adopt our fake animals?
Yeah, they will be able to click on your buttons and alter as we've mentioned in some other classes, whenever a user uses your application, they're able to CRUD things in your database. So people on the internet will be able to affect what is in your database. Just don't put your email anywhere so they can't like send you angry emails. Say like, where's my dog?
Thanks.
You're welcome. Dougie.
So we should, anything that goes into the deployed, anything that's deployed onto Heroku, I'm assuming needs to be like, we need to be absolutely sure that that is the not necessarily the final state, but like that it works exactly how we intended. Like we shouldn't be pushing up anything broken or partially working to Heroku, by my understanding, or
correct. Yeah. So maybe like a note that I could put in here, if I'm running out of room here. Yeah, that'll fit. We could say this is like the final completed code. This is kind of like your, if you could maybe think of like, if we're like writing a paper, development is the draft stage, the test is like the editing or copy editing stage, and then production is like the final draft stage. Now, Dougie, to your point, a lot of times when we push to production, things don't work because it is a different environment. So there are some things that behave differently in production versus local. So it might be the case that you might think something is working, and it might be working locally and it might be working in both development and test, but then you find when it goes up to production, it doesn't quite work the same. So do your best not to push any code that's broken, but inevitably you will find things that are broken just by nature of them being in a different environment.
Kind of a follow-up to that, is there a specific, like, I guess what's the example of something that could work locally and in test and not in production, and how would you go about fixing that without then breaking something in local and test?
Yeah, for this first project, there's probably not too many things that I can think of. But I think a pretty good example would be something like email. So maybe if in my tests locally are able to handle email really well, because it's just sending an email to myself in my own local environment, and it works just fine. But then maybe when it goes up to production, where the email actually has to go through the tubes of the internet, that's when things like break. So by nature of just something being on the internet, it kind of changes how the tech works. Another example would be something that requires an environment variable. So maybe we have an API key that we need to use an API. If we have that API key set up locally, but not in our production environment, that would break our production. So things that are specific to the environment. Something that I can show you to illustrate this really quickly would be just go to any Rails app. So yeah, here's the starter code for Adopt Gnome Shop. You'll see if I go into config, there are different files for, there's a file for, actually, here it is, environments. So there's a different environment file for development, production, and test. So everything that's in here are things that are different. So let's look at maybe production and development side by side. We can see that cache classes are not enabled in development, but they are enabled in production. Eager loading is not enabled locally, but it's enabled in production. There's this whole cache store thing, which is disabled in development, but not disabled in production. So really anything that's in these files is different, but I really don't need you to know specifics about these files. I just want to point out these files exist and they load up different things based on what environment is running. So there's a lot of different things that go into each environment. Joe?
Yeah, so and I'm sure you're probably already getting to this, but how do we, I'm assuming us like cloning or forking or whatever the repo has to do with Heroku, or like how does that work?
So what I'll do instead is I'll just kind of point you to the documentation. So if you look at this first story, and this is also linked in the story text as well, it shows you the guides that you need. So really your first thing that you should do is read through these guides and work through them to get your app deployed. That's probably the best resource. And then I would say like ask follow-up questions after that.
Okay, thanks.
You're welcome. Let me go back to my whiteboard here and make sure I save this version as well. Any other questions coming up? Alrighty then. Let me switch over to my desktop here. And something that I can show you is I can kind of peel back the curtain and show you what conveyor belt looks like on my end. So this app its job is to copy over that project board that I showed you. So it's going to create a fork for you and it's going to copy over the project board. And one thing that's interesting is that you can see what I was talking about before. Our app conveyor belt is hosted on Heroku. So we host on Heroku in order to make this accessible for all the instructors. So I can go to conveyorbeltherokuapp.com to use this app live from the internet. All right, so let's go ahead and make your new app. So we'll call this, what is this? Adopt, don't shop for 2102. And we'll give you all this project board. There we go. So I'm going to send you all this link in just a second. Well, actually, I'll just go ahead and put it into your cohort channel right now. And this is pretty straightforward. So it's going to, you can put your name in here, who will be working on this project. Because it's a solo project, you can just put your name. And it should auto-populate with your email, but if it doesn't, just put your email in here, click submit, and we'll get those project boards copied over to you. So go ahead and do that right now while we're on this call together. And I can do some monitoring on my side just to make sure that things look like they are working okay. Yeah, and so Wyatt, I see something didn't quite work with yours.
Cool. All right.
Yeah. I don't know why. So let's just give it a minute here and yeah, I'll see if I can figure out what's going on.
Do you want us using our full names, first name?
It doesn't matter.
Cool.
It says it forked over for me. Now I have everything.
Yes, sending to us like Sidekick or something.
Yep. Yeah, I see most of you are sending to Sidekick. I think Barisa's might be done. So let me do this and share this again. So what you should see, if this is completed correctly, it should send you an email. But what you need to double check when you get this repo, it's pretty good about copying over it's just forking for you. So it's pretty straightforward to fork. Make sure you go over to projects and you double check that you have a project board that has these 27 issues in the to-do. If you have that column with 27 issues, then you're good to go. So Brisa, can you confirm, did you get those 27
Yeah,
issues?
I have it and it's working and I'm cloning down right now. Thank you.
Cool. Yeah, it looks like Ksenia's is done. Joey, yours is done. Yeah. Cool. So if you got your project board and it's all done, I would say like you're good to jump off this call. That's all we have for today. So for the next couple minutes, please leave me some feedback on the many-to-many. I'd really appreciate that. And yeah, for the last couple minutes of close out today, I'll make sure everybody's up and running with this conveyor belt thing. So Wyatt, put collaborators, Brian Zanti, 404 not found. Do you have, Wyatt, do you have the repo?
Yeah, it looks like I do. It's there. Whitewix/adopt don't shop.
Yep, and there it is for me. So this is like a good insight into like some RESTful routing. So I'm looking at put, which would be an update to repos, Wyatt Wicks, adopt on shop collaborators, Brian Zanti. So I would think that that would be updating the collaborators with me. And it says 404 not found.
Well, so now on my projects, it's like slowly adding each to do. It's saying that I'm updating cards,
Oh yeah, I can see them right here.
but I'm not doing anything.
Yep, so that's the app is doing it for you. So we're utilizing the GitHub API to programmatically, we essentially hijacked your user and used it to programmatically create these cards. So it looks like your project board is populating here.
Yeah, just super slowly. It's weird.
Yeah. Oh yeah, there we go. And I can see that that message now changed.
Sweet.
Creating column 4. Huh. Okay. So that issue with Wyatt didn't seem to stop him. So I see Ryan, Olivia, Logan. Seems like you all have the same error message here, but if the same behavior works for Wyatt, then I think it should just push past it.
Are we supposed to get a link or something for the conveyor belt? I signed up, but I don't see anything coming through.
It should email to you when it's all done. I don't see you in here,
How long would we
Claudia.
expect that to take?
Probably like 5 to 10 minutes for it to finish all of these.
I got the email like 3 minutes after it was done with the job. So I don't think like it being completed is dependent on the email.
Yes. Claudia, you might, I don't know if you're referring to the link to fill out the form. That's in the cowork channel.
Yeah. I have the repo, but when I click on projects, I'm not getting anything.
Gotcha. Yeah, so Logan, I still see yours is stuck in the same error message. So Wyatt's just kind of continued on through that. So maybe we'll wait a couple more minutes and make sure that that's working.
Okay.
Why are we getting that? Yep, I see Kevin's is good, Alexander's is good, George, Ksenia, Khan, Joe, and Triple Joe is done. I see Claudia's in there.
Hey, Brian.
Yes.
I see that there's a branch, reorder stories. Should we just leave that alone?
Yeah, that's the last update that we did. Yeah, just leave it.
Okay.
That's the work that we did that I mentioned to shift around the order a little bit. Okay, Logan, yeah, it looks like yours is pushing through that error and is now creating your cards.
Yep, seems like they're coming in.
Awesome. Adding reference, I think that's the last step. Yep, I think yours is done, Logan.
Awesome.
Pretty confident that this is going to work just fine for everybody. Dougie, I see yours is starting. Olivia and Ryan's is starting. Don't think Claudia's has started yet.
Look, I'm a little confused. Am I supposed to be waiting? Like,
yeah, you're good. No, just wait.
Okay.
I'm a little unclear as to what I'm supposed to be doing. I seem to have gotten an email and I click on it and it brings me to this place and I have the ability to revoke access, which I don't think I want to do.
So I think this is yours, right? Icelandic Gambit?
That's Andrew.
That's Andrew Smith. Yeah.
Schaefer should be a philosopher.
Oh. Yeah, Andrew, I think yours is, yeah, I think it just started creating your, yeah, a philosopher. Yep, here's your board. It looks like they're coming through.
Okay.
Can you navigate to this, this repo and find your project board?
Let's see.
Yeah, it looks like everybody should be finished up except Aiden, Andrew, and Claudia. So if y'all can double check, you've got that project board, 27 stories, you should be good to go.
So is Conveyor Belt like a Turing app that you guys built, or is it something else?
Yes, it's an internal app. Yep. Yep. I'll probably talk about this some more later when we get into APIs a little bit. This is using the GitHub API to communicate programmatically with your GitHub account. Cool. I think everybody's done except for Claudia. So go ahead and double. Oh, and now Claudia's done. So go ahead and double check that you all have that repo, the 27 stories, and the to-do and the project board. And if you do, I think you're good to go.
I don't see anything in the projects.
Gotcha. Can you share your screen and show me what you see?
Okay. So this is what I see. Looks like there's 27 issues. Maybe that's what I'm supposed to be looking at, but under projects, it doesn't look like that. Wait.
Yeah, there you go.
Okay, here we go. Okay, it showed up.
Yeah, you're looking good.
Right, thank you.
You're welcome. All right, y'all. Claudia, is yours looking okay?
Yeah, I think I got it. It forked and has the projects. Yeah,
cool.
I think I'm good. Thank you.
All right, well, I'm going to close out the Zoom call unless any last questions before I do that. All right, y'all.
Brian, I had a question, if you don't mind. It's really not related to the class. It's a silly question if you have like 10 seconds to answer it.
Sure, what's up?
In the background, you have what looks like a wooden block. And some of our classmates were thinking it's a laptop stand. Some of us were thinking it's a wood a chopping board, a cutting board. And I was wondering if you could clarify and end the argument for us.
It is a cutting board. It is a cutting board.
Oh, cool.
Yeah, I got the story is that I got a new puppy. Not well, now this is 2 mods ago, but the start of last mod, and it used to be upstairs, but she really liked to chew on it, and I like it, and I don't want her to chew on it. So I figured I could repurpose it as like some Zoom decoration back here. So yeah.
That makes sense. Thank you for that. Someone said a chopping board, and I said, what good is a vertical chopping board, you know?
Yeah, exactly. No, I don't know if I've ever actually used it for cutting. It's kind of just decoration.
Yeah, it was nice. It's nice wood there, though. It looks nice, so I would understand that.
Thank you. Yeah, I made it.
Oh, really?
Yeah.
That's cool. Okay. Yeah. Thanks for that. I'm sorry for the silly question, but just thought it'd be funny to ask too. So.
No worries at all. Yeah. Thanks for asking.
Okay. All right. See you later. Hey, thank you for your help today. It was really long, but I think you did great. You know, considering it was just a long day in general. So thanks for your
Well,
time.
y'all get a break from me tomorrow, so that's how it works. All right. See y'all. Have a good evening.
Bye.